Okay, so inequalities of combined functions. There are two methods of solving inequalities of combined function. One is the algebraic method and the graphical method. So second method is the graphical method. Primarily, we're going to use the algebraic method when we have inequalities that is made up of the same families of functions. And we will use the graphical method when we are solving inequalities where we have a function that's part of different families of functions. So just to give you an example, if the functions are part of different families of functions, for example, if I have sine of x that is greater than log of x, this is a trig function, that's a logarithmic function, so they come from two different families of functions. In order for me to solve this or to figure out the intervals in which this function is true, I would have to basically graph both of the functions and estimate the solution to figure out where sine of x would be actually greater than log of x. And we're going to do the same question here in one of the examples for this lesson. Just to do a little recap, the algebraic method we are only going to be using when we have functions that are part of the same family. So we're using an algebraic solution. That's the most efficient way of solving. And the graphical representation is used when we are solving our inequalities of combined functions that come from two different families of functions. And also to do a little recall, whenever we are solving an equation where one function is equal to another function, we primarily move everything to one side and make the right hand side equal to 0. And we do the exact same thing for inequalities. So for example, if I have f of x is less than g of x, I would move the g of x over, so I would have f of x minus g of x less than 0. And we then figure out the intervals in which this inequality is true. And we generally write down our solution in interval notations for inequalities. All right, let's go ahead and do an example. So the first example that we're going to be doing is solve for the equation cos of pi over 2x equal to square root of x. Notice here this is not an inequality. This is an equation of combined functions. So we're trying to figure out where are the two equal to each other. So the point of intersection in this case. And solving this algebraically is going to be very difficult. In fact, it is not feasible to do it algebraically because of the fact that I have two different families of functions. I have a square root function here. And over here, I have a trig function. So since I have two different types of functions, the best way for me to actually solve to figure out the point of intersection would be to graph both of those equations. So I'm going to go ahead and I'm going to start off by graphing cos of pi over 2x. Okay, so I'm just going to choose different values of x here. I'm only going to stick to the right side of the x-axis because I do know that the restriction or the domain for square root of x is that x has to be greater or equal to 0. So I'm just going to stick to that. And I also notice the fact that since I'm calculating the square root of x, I'll go up to maybe where I'm able to calculate a square root of 3. So I'm going to go all the way up to 9 from x-axis. So here I have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. You don't necessarily have to. You can be 64 and see where those intervals are equal to each other. If you're able to figure out the point of intersection, you don't have to elongate your x-axis. However, I just want to see the full picture, so I'm just going to go ahead and do that. So let's go ahead and graph cos of, positive 1, and that's a negative 1. Cos of pi over 2x. So when x is equal to 1, I have cos of pi over 2. And if you want to use your calculator, you can go ahead and do that. I'm just going to show you with the calculator what that would equal. You guys already know how a coarse graph already looks like. So cos of pi divided by 2, that is 0. So x is equal to 1, that's 0. And when it's equal to 0 here, cos of 0 is equal to positive 1. And I'm just going to go ahead and use my, just going ahead and graphing cos of pi over 2x by subbing in different values for x. If x is 2, that's cos of pi, that's negative 1. Plugging in 3 would be 0, and 4 will be 1 again. So just continuing that pattern. Okay, and I'm just going to go ahead and graph my cos of pi over 2x function. Alright, so that's cos of pi over 2x. Now I'm just going to go ahead and graph square root of x. So square root of 0 is just 0, square root of 1 is 1, square root of 4 is 2. Square root of 9 is 3. So those are my key points. And now whenever you are graphing and you're trying to figure out the solution through a graph, you do have to estimate. So just try your best in terms of figuring out where that point of intersection is. So in this case, I'm going to approximate that x is approximately equal to 0.5. So I've just solved this equation in a graphical notation because of the fact that I have two different types of functions. And I'm just trying to figure out where do those functions intersect. And in this case, it's approximately at 0.5.